Vue.js is a progressive JavaScript framework that enables developers to create interactive user interfaces efficiently. And now, with Vue.js 3 on the scene, we've seen some exciting changes compared to its predecessor, along with enhancements that really make Vue applications more robust and performant. So, today, we're going to dive deep into the world of Vue.js applications, focusing on the latest features and how we can leverage them effectively in our projects. Whether you're a seasoned developer or just starting, there's something new to discover. Let's get started. So far, we've learned how to create a Vue.js application, set up components, and manage state using Vuex. We explored the utilization of Vue.js dev tools for inspecting components and monitoring state in real time, which really enhances our debugging process. We also integrated Vuex with our components to streamline state management and introduced unit testing to ensure the accuracy of our application behaviors. Finally, we emphasized the importance of combining these tools for a more efficient development experience. Now, let's dive into some exciting features of Vue.js 3, particularly its composition API, and see how we can enhance our applications using these new tools. First, you'll notice the composition API allows for a more flexible way of organizing your component logic. Instead of grouping everything by options like data and methods, we can group related reactive state and functions together. This promotes better code readability and reusability. So, to get started, let's import the ref function from Vue and create a reactive variable. Just type const count equals ref of 0. Now, every time we need to update our count, we can do it easily and reactively. Amazing, right? And while we're at it, we can define functions that operate on this state right alongside it. For example, let's create a method to increment the count. Const increment equals do count.value++. See how that flows? Keeping related logic together makes it so much easier to manage. Now, let's talk about lifecycle hooks in the composition API. Instead of using methods like mounted within the options API, we can now directly use onMounted. Just add onMounted, parentheses, open curly brace, console.log, open quote, component is mounted, close parentheses. Isn't that a neat simplification? With Vue 3, we also get enhanced TypeScript support. So, if you're into type safety, you're going to love this. It makes it easier to catch errors during development, leading to more robust applications. And remember, all these tools combined, from the composition API to TypeScript, help you build more efficient applications. So, in our next sections, we'll explore even more features and practical examples to elevate our Vue.js skills. One of the most significant changes in Vue.js 3 is the introduction of the composition API. While the options API was the hallmark of Vue.js, the composition API takes things up a notch, allowing developers to compose their component logic in a much more flexible manner. This flexibility means you can create cleaner and more reusable code, especially if you're working on more complex applications. So, let's dive a little deeper into this and see how it works. This pie chart titled Key Concepts in Vue.js Applications reveals 5 key components and their relative proportions. So, let's break this down. First up, we have the Composition API, which takes the largest slice at 35%. This really underscores the primary emphasis on compositional patterns and local reactive logic within Vue applications. Next, we see state management sitting at 25%. This highlights its ongoing significance for centralized data handling, especially when used alongside those compositional techniques. Moving on to performance, it occupies a substantial segment at 20%. This tells us that runtime efficiency is an essential concern for developers. Now, both TypeScript and SSR/SSG are represented as smaller segments at 10% each. They certainly hold relevance, but they're not the main focus in this distribution. So, when we look at the overall pattern, it suggests a clear prioritization. Core architecture and reactive composition, specifically the composition API combined with state management, account for a robust 60% of the focus. Performance follows as an essential secondary concern, while TypeScript and SSR/SSG provide important, albeit more specialized capabilities. From these proportions, we can draw an interesting conclusion. Focusing your time on mastering the composition API and effective state handling will yield the greatest impact on your Vue projects. And of course, don't forget to also plan for performance optimization and consider incorporating TypeScript or SSR/SSG depending on your project needs. Now, let's take a look at a simple counter component built using the composition API in Vue.js. We start by defining a template that has a heading displaying the current counter value, and there's a button that increments this value when clicked. Within the script section, we import the ref function from Vue. This is super important as it lets us create a reactive reference for our state variable, which we'll call count. All right. Inside the setup function, we initialize count to 0, which is our starting point for the counter. Next, we define an increment function that bumps up the value of count by 1 every time we click that button. This reactive pattern is essential because it makes sure that any updates to count automatically show up in the UI. Yay! No extra manual DOM manipulations required. Finally, we return both count and increment, so they're accessible within the template, which allows the user to interact with the counter seamlessly. By using the composition API, we keep our structure organized, enhancing the component's reusability and maintainability. Now, let's take a closer look at a really simple yet powerful example of a composable function that manages a counter. We're going to kick things off by importing the ref function from Vue. This is super important because ref helps us create a reactive reference for our count variable, which allows Vue to track its changes over time. Next, we'll go ahead and define the useCounter function. This is where we'll wrap our countdown logic. Inside, we'll initialize count to 0, which gives us a nice starting point for our counter. Now, we need to create two methods, increment and decrement. The increment function will boost the value of count by 1 each time it's called, while the decrement function will lower it by 1. These handy little functions help encapsulate the behavior we need to mess with the counter, sticking to the principles of the composition API by promoting reusability and keeping our code nice and clean. Finally, we'll return an object that includes count, increment, and decrement. This lets any component that imports this composable dive in and interact with the counter state effectively. So, this approach ensures that multiple components can share the same logic while keeping their own states intact, which enhances consistency and really helps reduce code duplication throughout the application. Next, we're diving into a performance-focused example that showcases Vue.js 3's impressive reactivity using a straightforward list management system. To kick things off, we'll create a reactive reference called items. This will hold an array filled with 10,000 unique elements, which we'll generate using the array and keys methods. This method effectively simulates handling a large dataset, allowing us to witness the advantages of Vue 3's reactivity firsthand. Now, let's take a closer look at the update items function. This is the function that modifies our items array. When it runs, the function adds a new item at the end of the list, increasing the total number of items displayed. Notice how by using the ref function from Vue, we can maintain reactivity. It ensures that only the necessary parts of the DOM get updated when we append an item. This streamlined updating process really highlights the benefits of Vue 3's proxy-based reactivity system, which I must say is way faster and more memory efficient compared to its predecessor. By observing how smooth this operation is, you'll really appreciate how Vue 3 caters to complex applications with extensive data management needs, resulting in a surprisingly responsive user experience. Next, we will write a Vuex store to manage the global state for our shopping cart application. To get started, we need to import the create store function from Vuex. This is essential for setting up our centralized state management. Now, when we define our store object, we have several key properties: state, mutations, actions, and getters. The state property holds our application's initial state, which, in this case, is an empty shopping cart represented by an array. Moving to the mutation section, we're going to define two important functions: add to cart and remove from cart. These functions take care of updating the cart by adding or removing products based on their IDs. Using mutations is a great way to follow Vuex best practices, ensuring that our state changes are predictable. Next up, we have the actions property, which includes a function we've named addProduct. This function commits the add to cart mutation, helping us understand how we can interact with the state asynchronously. It's kinda cool, right? Finally, in the getter section, we get a nice, convenient way to access computed values from our state. For instance, we can retrieve the total number of items in the cart, which is super handy. This structure supports organized and efficient state management, allowing us to integrate it seamlessly with our Vue components. Now let's see how we can implement a cart component that interacts with our Vuex store using the Composition API. In the template section, we display the current item count in the shopping cart, making it responsive to state changes. The button provided allows users to add a product to the cart, showcasing a straightforward interaction. Okay, within the script, we first import necessary functions from Vue and Vuex, specifically computed for those reactive properties, and useStore for accessing our Vuex store. Now, the setup function is where we define our component's logic. Here, we create a store instance by calling useStore, allowing us to directly access those Vuex properties and methods. Next, we define cart count as a computed property to retrieve the number of items in the cart through the store's getter. This ensures that our component reflects real-time updates to the cart. The brief pause function is responsible for dispatching the action to add a product to that cart. And finally, we return cart count, add product, and a sample product object, making these properties seamlessly available for our template to use. Now, let's implement a simple TypeScript-based Vue component to understand how we can leverage TypeScript's features. In this example, we'll define a basic template that renders a heading displaying a message. By utilizing script langTS, we declare that we're writing our script in TypeScript, which not only enables us to integrate type checking, but also makes our components so much more robust. So, the define component function from Vue is imported to help us outline our component. Inside the component's data method, we return an object containing a single data property, message, initialized with the string hello Vue with TypeScript. This sets the foundation for our component's reactivity, allowing the message to be displayed on the screen. Now, when we leverage TypeScript, we enhance our application with better tooling support, making refactoring and maintaining our code a breeze. Plus, it encourages the use of interfaces and type definitions, which leads to fewer bugs and a clearer understanding of our data structures. In summary, this example illustrates how to create a fundamental Vue component while taking advantage of TypeScript for improved code safety and maintainability. Now, let's implement a basic setup for a Nuxt.js application, which plays a crucial role in enabling server-side rendering. First, we initiate the project using npx create Nuxt app my app, and this step sets up all the necessary files and configurations for our application. During this installation, you'll be prompted to choose features like TypeScript, Axios, and Vuex, which allows you to customize your setup according to your preferences. Next, we'll create a simple page under the Pages directory. This is a vital aspect of Nuxt.js because these pages will correspond to routes in your application. We'll define a template that includes an h1 element to welcome users to our Nuxt app. Here, we also utilize the async data method, which is a powerful feature in Nuxt.js. By placing our data fetching logic within async data, we ensure that our data is retrieved on the server side before rendering the page. This means users will experience faster load times and improved SEO performance since the fetch data is available right when the page is first served. Overall, this approach really simplifies the process of creating an optimized application using Nuxt.js. As we wrap up, it's really important to emphasize the evolution that Vue.js has undergone to serve modern development needs. Like, wow! The composition API, improved performance, enhanced TypeScript support, and SSR capabilities, all of these play a vital role in building sophisticated applications. Vue 3 equips us with tools that not only simplify component development, but also enhance maintainability and resource efficiency. By understanding these essential features and applying the concepts we've discussed, you'll be better equipped to create powerful, responsive, and user-friendly Vue.js applications. The development landscape is ever-changing, and with tools like Vue, adapting to these changes is, with excitement, seamless and truly exciting. Now, in the next session, we'll cover specific patterns for building modular components and explore transitions and animations to enhance user experience in our applications. Thanks for joining me today, and happy coding!